Welcome everybody. There may still be people trickling in, but I think also it's good to get the show on the road because it's going to be a very exciting next hour. Good afternoon and a very warm welcome to everybody to the third William F. Brace lecture. I'm Robert van der Hilst. I'm the head of Department of Earth, Atmospheric and Planetary Sciences. This lecture is named in honor of William Brace, or Bill Brace, as we know him. He was a very well-known and respected professor of rock physics who became the first head of department of the Department of Earth, Atmospheric and Planetary Sciences. In 1983, as many of you know, he oversaw the merger of two departments, Course 12, which we still are. Course 12 at that time, in the late 70s, was called Earth and Planetary Sciences, and that merged with Course 19, which was Meteorology and Physical Oceanography, to become EAPS, Earth, Atmospheric and Planetary Sciences, the department that we are now today. EAPS, the research themes that that basically characterize us is Earth, planets, climate and life, in particular the origins and evolution of life, and much of our science is highly interdisciplinary. Bill Brace retired in 1988 from academic life and took up his second passion, which is fine furniture making, and he did it for almost 20 years. Unfortunately, in 2012, he passed away, but I'm delighted to welcome here Mrs. Peggy Brace. Peggy, back in the audience. It's wonderful to have you, Peggy, here, and of course you will join us later also. And I also understand that your children, Sarah, Nathaniel, and Colin, are probably watching us also. So Sarah, Nathaniel, Colin, welcome to the show. We miss you here, but I hope you, from your remote locations, you can still enjoy what we are doing today. So welcome everybody here. The Brace Lecture gives us an opportunity to showcase the Earth and planetary sciences in an accessible and thought-provoking way. And so it is with great pleasure today that I can introduce to you David Grinspoon. Dr. Grinspoon is a senior scientist from the Planetary Science Institute, and his astrobiological research and writings have resulted in numerous awards, from the Carl Sagan Medal for Public Communication of Planetary Science to the Penn Center USA Literary Award for Nonfiction. His website, funkyscience.net, tells us something about his ability to translate science to a general audience and also about your sense of humor. And I'm sure we're going to witness some of that later this afternoon. David, thanks so much for being here. We are all intrigued about your work and encouraged that you've been described as an optimist. After all, TED.com put your book Earth in Human Hands, which we have a copy of here, and it will be available after the lecture, on a list of books to make you feel hopeful. So we eagerly await your thoughts on the future of the Earth. Thank you for being here, and the floor is yours. David?
No, I got my own mic. Well, thanks very much for that generous introduction, and thank you all for coming out this afternoon. I want to talk to you a little bit about my new book, Earth in Human Hands, and why I wrote it, take you through a little bit some of the ideas in the book and my thoughts on the subject, and then make sure that we leave enough time to have some of your questions and comments and hear some of your thoughts. Let's see. So I want to start by telling you a little bit how I came to work on this project, because it's a little bit of a detour from perhaps the main path of my career. Before I do that, though, I had one quote loaded up here that I wanted to share because it's a favorite of mine, and we just had Black History Month last month and celebrated Martin Luther King Day. And this is one of my favorite quotes from Dr. King that I think also perhaps sums up a little bit of one of the ideas that I hope comes across a little bit in this book. The idea that, according to Dr. King, that if we are to have peace on Earth, and I also interpret that to mean if we're to build a sustainable society, our loyalties must transcend our differences, and in some way we must develop a world perspective. And it is my belief, and one of the points I've tried to make, that if we look at our world and our species, our role in our world, through the lens of what we learn through a deep consideration of earth science and of human history, deep human history, meaning millions of years, if we look at the truth of what we learn about our world through deep time and through the global perspective afforded to us from space exploration and Earth observations, then that naturally leads us to a kind of a world perspective. So there's a way in which, just by telling the truth of what we know, that what we've learned about ourselves and our planet through science, that I think it does promote this kind of view, which is fortunately a kind of view that we will need to survive. This project for me is a bit of a departure in the sense that I'm trained as a planetary scientist, and through most of my career I've worked in planetary exploration and astrobiology. But nonetheless, I've written a book now about humans on Earth. The opportunity to write this book came about through, for me, through an ad that I saw about 4 years ago for a new position, an astrobiology chair at the Library of Congress. And in particular, as you can see in the description here, they were seeking somebody to undertake research at the intersection between astrobiology and its humanistic aspects. And by the way, part of the reason I'm putting up this ad here is also to advertise. That's what ads are for. But this is still a relatively new position, and those of you that are scholars in the sciences or in the humanities that are interested in this kind of question, it's a really great deal. It's a wonderful opportunity, and they're looking for people to apply. It's still relatively new. Not that many people know about it, so if you've got that idea you've been dying to pursue on sabbatical that's a little bit different from the mainstream of your field, but that might broadly fit into this, I encourage you to think about applying. But at any rate, when I saw this ad, I thought, wow, maybe that's the opportunity to write this new book I've been thinking about and haven't had time to pursue, that broadly speaking is on this topic. This was actually the title of my proposal that I wrote for this, Astrobiology in the Anthropocene Era, exploring the roles of life and intelligence on Earth and beyond. And fortunately for me, my proposal was accepted, and I was named as the inaugural astrobiology chair and had a wonderful year. I managed to stretch it into almost 2 years at the Library of Congress, working on this project, which was the beginning of this book that has just recently finally been published several years later. So I want to take you through a little bit of that. And what I'm going to do to start off is read you a short passage from the very beginning of the book in which I attempt to answer the question, why is an astrobiologist writing a book about humans on Earth? After all, we study aliens on other planets, right? So here's my attempt to frame that. This is from the introduction. It's called A Planetary Perspective on the Human Predicament. Gazing over the countless fluctuations and transformations in Earth's multi-billion-year history, I am struck by the unique strangeness of the present moment. We suddenly find ourselves sort of running a planet, a role we never anticipated or sought, without knowing how it should be done. We're at the controls, but we're not in control. This book is my view of how we got into this situation and where that leaves us now. Although climate change is the most obvious, it is only one of a large number of interconnected ways in which we have suddenly begun to modify the planet we inhabit. The scientific community is now converging on the idea that we have entered a new phase or epoch of Earth history, one in which the net activity of humans has become a powerful agent of geological change, equal to the other great forces of nature that build mountains and shape continents and species. The proposed name for this new epoch is the Anthropocene, or the Age of Humanity. This concept challenges us to look at ourselves in the mirror of deep time, measured not just in decades or centuries or even in millennia, but over hundreds of millions and billions of years. We are witnessing and manifesting something unprecedented and still completely unpredictable, the advent of self-aware geological change. As an astrobiologist, I study the possible evolutionary relationships between life and the planets that may host it. I see the Anthropocene as a tricky new step in the long, intricate dance between Earth and its biosphere that has been going on for 4 billion years. There are those who object to the name Anthropocene as being too self-aggrandizing and serving a destructive, human-centered viewpoint. But this epoch is well named because it represents a recognizable turning point in geological history brought about by one species, Anthro. And our growing acknowledgement of this inflection can be a turning point in our ability to respond to the changes we've set in motion. I believe that more than the extreme and undeniable physical changes to the planet being caused by human influence, it is this dawning self-recognition that is really fundamentally different and ultimately promising about the Anthropocene. Many species have changed the planet to the benefit or detriment of others, but there has never before been a geological force aware of its own influence. Okay, and then a little bit later, also in the introduction, I'll just read you a snippet where I talk about the planetary perspective. It may seem circuitous to begin a book about the human role on Earth by talking about the exploration of other planets. I will try to make the case, however, that looking homeward from the vantages we've gained through our interplanetary journeys gives us valuable perspective for navigating the planetary scale changes we are now facing and causing. We need to learn all that we can about how planets work so we can make the transition from inadvertently messing with Earth to thoughtfully, artfully, and constructively engaging with its great systems. The planetary perspective allows us to step away from the noise of the immediate present to see ourselves from a distance, in time lapse. When we do so, what we see is not just a problem facing our civilization, but an entirely new evolutionary stage in the development of life. In seeing ourselves as a geological process, we also see the planet entering a phase where cognitive processes are becoming a major agent of global change. Earth's biosphere gave birth to these thought processes, which are now in turn feeding back and reshaping its changing planetary cycles. A planet with brains? Fancy that. Not only brains, but limbs with which to manipulate and build tools. We are just beginning to come to grips with this strange new development. Like an infant staring at its hands, we are becoming aware of our powers, but have not yet gained control over them. And I got one last little bit from the intro that I'm going to read. The planetary perspective provides a kind of out-of-body experience for us, hovering in orbit and watching ourselves sleepwalk through a slow disaster of our own making. Now, can this experience help us to shake ourselves awake? For virtually all of its history, Earth has evolved without us, and we have always seen ourselves as autonomous actors on a passive planetary backdrop. But now, we are beginning to see that our futures, those of humanity and of planet Earth, are tightly conjoined. If human civilization is to persist and to thrive, we will need a completely different view of our planet and of ourselves, one in which we acknowledge both our deep dependence and our increasing influence. We need visions of a future in which we have applied our infinite creativity to the task of living on a finite world, where we have embraced our role, become comfortable and proficient as planet shapers, and learn to use our technological skills to enhance the survival prospects, not just of humanity, but of all life on Earth. My name for this vision is Terra Sapiens, or Wise Earth. A recent scientific breakthrough enriches this story: the exoplanet revolution. As we long suspected and have now confirmed, this universe is full of planets, orbiting nearly every star. It is now very close to inconceivable that we could be the only life and only technological intelligence in the universe. An interplanetary perspective on Earth's current dilemmas incites us to wonder whether parallel dramas may have unfolded on distant worlds. Do other planets also grow inventive brains that end up causing themselves problems? Do other species develop technology and build civilizations that create dangerous instabilities on their planets? How do they cope? Do planetary biospheres become self-aware? The Anthropocene leads us to a new way of looking at SETI, the search for extraterrestrial intelligence, which in turn illuminates changing notions about ourselves, how we fit into our planet, and what kind of future we dare imagine. 100 million years from now, what will our time have been? A brief climate spasm that Earth shrugged off and largely forgot, leaving a thin layer infused with bizarre plastic objects? Or the beginning of a lasting new phase, when the biosphere finally woke up and adjusted its grip on the planet? Okay, so that's all from the intro, kind of setting the stage, giving you the scope and perspective that I try to bring to the book. The first chapter of the book then is called Listening to the Planets. And it's where I sum up what we've learned from the space age, from planetary exploration and Earth observation, what we've learned from all that exploring, but with a focus on what we've learned about our home planet from going elsewhere in ways that may help us now sort of figure out what we're doing here and how to deal with ourselves. The advent of our ability to leave the planet and look back led to an explosion of insight about our home planet. It's like that T.S. Eliot poem, at the end of all our exploring, we return to the place we started and see it as if for the first time. I think T.S. said it a little bit nicer than that, but that's the basic paraphrase. You learn, there's some things you can learn only by leaving home and looking back. And there are several sort of eureka, aha moments, insights about our own planet that fell out of this exercise. And especially the early decades of the space age were an extraordinary time of advancement in understanding about the Earth. For one thing, the theory of plate tectonics, which now is understood as the unifying idea that unites all the Earth sciences, at the beginning of the space age was seen as a fringe, unlikely theory, this idea that the Earth's surface was split into about a dozen, 12 or 13 solid plates, rigid plates that slide around with respect to one another, and where they interact, pulling apart and squishing together and sliding over and under each other. That's where most of the action happens geologically on Earth. And plate tectonics is not just a theory about what happens on the surface of the Earth. It also reflects, now we understand, currents in the deep interior of the Earth, the convection currents in the mantle that the plates ride around on, and the climate itself, all the great chemical and geochemical and what we now call biogeochemical cycles of carbon and nitrogen, oxygen and sulfur and so forth. Plate tectonics is wrapped up and controls a lot of that. So even the climate of Earth and the carbon budget and so forth in the long run are connected to this whole system of churning surface and churning interior and churning atmosphere that we really didn't know about when we started to explore. It wasn't just from space exploration that we learned about this. A key bit of data, a key area of data to understand plate tectonics also came from ocean exploration, mapping the deep ocean. But that, ironically, also came out of Cold War competition. So these two great sets of insight really in the 1960s of the ocean floor and seeing Earth from space, which together combined allowed us to understand our planet in a whole new way that may aid in our survival, both came out of this deathly competition of the Cold War. There's some interesting historical irony there. At any rate, so there was plate tectonics, another great insight that came out of the space age had to do with, or a series of insights, had to do with the interaction between Earth and the rest of the solar system, that we're much more connected than we thought we were. One obvious way is through the impact of objects, of extraterrestrial objects affecting Earth history. When we look at the moon, of course, we see that it's full of holes because it's been hit over the eons by high-velocity objects that are traveling through the inner solar system and occasionally hit planets. So why isn't Earth full of holes? Why hasn't Earth been hit? Well, of course it is, and it has. It's just that the signs are a little more subtle. It's been covered up because Earth is constantly remaking its surface through this plate tectonic repaving, but also through the great meteorological and biological activity of Earth. So the signs are a little bit more subtle, but once we knew to look for them, we now understand that Earth has a really deep and important history of impact from extraterrestrial objects. Most famously, probably the what we call the KT impact, or the big comet or asteroid that hit 65 million years ago and wiped out not just the dinosaurs, but more than 75% of all animals at that time. So Earth is connected to the rest of the solar system in a multitude of ways. There's also a series of interesting connections that have to do with climate. Cycles of climate, it turns out, on Earth are controlled by the orbital influence of the other planets, mostly Jupiter, because of its great mass. This is, again, something we only discovered relatively recently. There are these complex cycles of ice ages and hot houses and interglacial periods where the temperature goes up and down in a complex rhythmic pattern over the eons that is related to the orbital tug of the other planets. We call these Milankovitch cycles because the theory of this was worked out in, I think, published in 1918 by a Serbian mathematician named Milutin Milankovitch. He worked out this theory while he was a prisoner of war in World War I, published it, and nobody believed it. People thought he was a crank. He died in 1958, just at the beginning of the space age, went to his grave with everybody ignoring this idea and thinking he was a crank. Shortly thereafter, we discovered the evidence of the climate history, largely through actually looking at ice cores on Earth, and saw patterns that perfectly matched his predictions. And now these are called the Milankovitch cycles, and they are understood to control the long-term climate cycles of Earth through the gravitational interactions of other planets. An interesting wrinkle to this is that more recently, scientists studying the evolution of humanity, digging up bones in East Africa and putting together the history of our own species, have come to understand that the history of ice ages in Africa over the last couple million years have been key to the evolution of modern humans. If you think of most of the major innovations that we associate with what makes us human, you think of upright walking, large brain size, domestication of fire, different aspects of the use of language and collective intelligence, collective planning, and various social and material technologies. A lot of these innovations came about through it came about during times of climate change and climate stress, and when in response to survival threats that were related to climate change in Africa. And there's a section of the book where I go into more detail about that, but the punchline is that even our own evolution and some of the key steps that made us human beings are related to these climate changes, which are ultimately driven by the orbits of the other planets. So there's some really fascinating connections that we've learned by piecing this all together. Another thing that we learn when we do comparative planetology, and this is what I actually do for my day job, is I study the climate evolution of Earth-like planets. So Venus, Earth, and Mars makes a really interesting trio because there are two neighboring planets that are both somewhat Earth-like in different ways. And one thing we've learned through exploring these planets is that they all started off with fairly similar environments. As far as we can tell, Mars and Venus, when they were young, were much like Earth when it was young, with warm oceans, geological activity, plenty of organic matter. And so they may have all had the conditions for the origin of life. And it may be that the universe is telling us that rocky planets often start out this way. And what's rare may not be the conditions for the origin of life, but the persistence of habitable conditions. And one thing we're still trying to understand on Earth is how the role of life itself has helped to maintain those habitable conditions. But one thing becomes very clear when we study these planets, this trio of worlds, is that their story in some ways is a divergence from more common conditions. And early on in their histories, all three of these planets went through some kind of catastrophic transition. In the case of Venus, on the left, it went through what we call the runaway greenhouse and ended up a desiccated, self-cleaning oven. In the case of Mars, Mars is too small to hang on to a thick atmosphere and hydrosphere. It lost much of its atmosphere to space. It became cold and dry. To continue the kitchen analogy, if Venus is the self-cleaning oven, Mars is the deep freezer you've got in your basement. Neither of those planets has obviously habitable conditions today. Mars possibly does somewhere down in the depths. Venus may even somewhere up in the clouds. But certainly neither of those planets is flagrantly taken over by life in the way that Earth is. On Earth, there was a catastrophic transition fairly on where Earth became alive. And especially in contrast to the lifeless neighbors that we've now had the opportunity to explore, we've become very aware of the pervasive role of life in remaking our planet. Earth is a planet thoroughly taken over by life, not just the obvious signs of life that you would note, any casual observer would notice from light years away, like the flagrantly oxygenated atmosphere that is very different from the air of a lifeless planet, but other more subtle signs, the rocks themselves. It turns out that more than 2/3 of the minerals of Earth are in some way products of biology. And even perhaps the interior of the planet, the deep interior, which we have always thought of as off limits to life because as far as we can understand it, nothing can live deeper than a very thin part of the crust where it's relatively cool. But now we're starting to understand through these geochemical cycles, these deep geochemical cycles I alluded to earlier, that the interior of the Earth, its chemistry and therefore its material properties have been altered by life. And it may be that life is even in some way in control of the motions and properties of the interior of our planet. So Earth is a thoroughly living planet in that sense, and it's something that we really learned through the process of exploring the other planets. You can look at this as a juncture that Earth turned down, a path that Earth took early in its history that differentiated it from that of its lifeless neighbors. Earth took the path of life. And I present it that way in the book as sort of a setup to the next part of the book where I start talking about human influence. Because it's my contention that we are now potentially at another moment of transition in the life of the planet, which in its own way may be as profound as the origin of life, as far as a fundamental shift in the way the planet operates. The advent of cognitive life, if it sticks, if it's not just a flash in the pan, may in fact be another juncture that our planet has come to. And so the next chapter of the book, where I sum up human influence from the planet's point of view, sort of. I describe humanity, how we seem from the Earth's point of view. This is a section of the book called Monkey with the World. And I'm going to read you just a little bit from the very beginning of this section, from a little subsection called, that's the wrong chapter. Oh, here we go. From a section called Something New. Starts with a Grateful Dead quote. Who can stop what must arrive now? Something new is waiting to be born. Have you noticed that something strange is happening to Earth? Take a good long look at this world, a dazzling blue orb festooned with spiraling clouds, spinning through star-flecked darkness, dayside glinting in slowly brightening sun, winter white pulsing between north and south as Earth ambles through its orbit. Now, imagine you are a very patient alien regarding Earth over the eons. If you've been watching carefully for, say, the last several billion years, you've seen a lot happen. The brown continents drifting around the oceanic globe, coalescing and breaking apart, animated pieces in a morphing spherical puzzle. The polar caps growing and shrinking, advancing and retreating, as climate rocks between ice age and hothouse. Throughout all these changes, the night side remains a nearly unbroken black, and the dayside continents are the stark, dull gray of bare rock. After 4 billion lonely years, a green fringe first edges over the land, and the night starts to sparkle with occasional forest fires. Still, for the longest time, the unlit hemisphere remains as black as the starry space surrounding it, the dark interrupted only by these fleeting fires and by occasional flash of lightning or splash of aurora. Until, very recently, in the last few hundred years, just a twitch in the life of the planet. Whoa, what is this? Something new. Suddenly, the planet lights up in a peculiar spidering pattern that seems to reflect an organic process, but something else as well, something cognitive. Starting in a few isolated river valleys and coastal areas, glowing points appear, abruptly dotting the night, then stitching together and spreading along widening and brightening webs, hugging the shores and eventually growing in loose nodal patterns across the interiors of the lands. On the day side, a mesh of dark lines becomes visible, winding between the locations of those night lights, each swiftly surrounded by a growing verdant grid of novel angular geometry. Soon, regular movements of small wave-generating objects start crossing the oceans, and bright linear clouds start streaking the skies. At the same time, a host of other accelerating changes are observable in the atmosphere: the land, the oceans, and the ice. Finally, just 60 years ago, a blink and you missed it interval in this fast-forward view, began the curious anti-accretion, with small bits of Earth stuff jumping back into space. Little insect-like constructions of refined metal, bristling with sensors, thrusters, and radio antennae, started leaping back off-planet, sallying first to the nearest worlds and then to those farther afield, sending pictures and other information home to their inquisitive builders, signaling the arrival on Earth of curiosity and gravity-defying technology. Yes, after billions of years of geology as usual, something new and strange is definitely happening here. What is the meaning of these new changes? And then, I tell you, the next part of the book is my attempt to characterize the nature of this transition in the context of deep Earth history and looking at the other major transitions that have happened to the planet and also that happened to planets. So I bring in a little bit of comparative planetology to this. And I ask, what are the major kinds of transitions that can happen, and how do we stack up as change agents? Because after all, when you study the deep history of the planet, you realize that we are not the first species to come along and seriously mess the place up. For instance, these little guys, the cyanobacteria, they look innocent enough, don't they? But 2.5 billion years ago, they wreaked havoc, caused a massive change in the atmosphere and the climate. They did this because they discovered a new energy source. and they exploited the hell out of it. They were so successful at this that they poisoned the atmosphere and wrecked the climate. Sound familiar? What these guys discovered was solar energy, photosynthesis, using photons of sunlight to break apart carbon dioxide and water molecules, making organic molecules out of the carbon, which is food and fuel, and spitting out this waste gas, O2, oxygen. That was the poisonous gas that they filled the atmosphere with. Now, we, of course, don't think of oxygen as a dangerous poison. Personally, I love the stuff. But the thing about oxygen is that it reacts very powerfully with organic molecules, the stuff that life is made out of. And these are exothermic reactions. It releases energy and happens very willingly, given the least provocation. So when oxygen first appeared in the atmosphere and life had not evolved to take advantage of these reactions, it was very toxic and very dangerous and led to a lot of extinction of all life that sort of couldn't hide from it in what we call anoxic places, places that are hidden from the atmosphere in some way. Now, of course, life has evolved to use these very same powerful reactions. We call that respiration. And in every cell of your body, there are little power plants that, in a controlled way, do this reaction of oxygen with organic matter and release and store the energy. And that's how we live. So this is a common theme in evolution, that something that is a disaster turns into a boon for what evolves in the wake of the disaster. But the other part of this story is that this was undoubtedly the greatest chemical catastrophe in the sense of a rapid chemical change in the history of the Earth. And it probably led to a great climate catastrophe too. Right around the same time when all this oxygen appeared, we see evidence of what we call the Paleoproterozoic snowball Earth, where Earth became almost completely, perhaps completely frozen over for a time, so deeply that it might have almost led to the complete extinction of life, although it didn't, because the volcanoes came along and saved us and pumped CO2 into the atmosphere and eventually melted off. But many of us believe that this climate catastrophe came about also because of the presence of the oxygen, that at that time Earth was being warmed by a methane greenhouse, and oxygen reacts powerfully with methane and destroys it, and that could have led to the collapse of the methane greenhouse and the freezing of the Earth. These details are still being worked out and are somewhat controversial. It's no question that the cyanobacteria pumped oxygen into the atmosphere and that poisoned life. The connection with the climate catastrophe is still a little bit being worked out. But the point of raising this here is that we hear this story and we understand that we are not the first species to come along and mess up the planet. But yet, still, something is obviously very different here. When we discuss this story, we don't find ourselves saying, those irresponsible cyanobacteria, what were they thinking? We don't say that because they were bacteria. And we know they don't think, or we don't think they think. Unless, of course, you consider that in some ways we are colonies of billions of bacteria ourselves, and then bacteria are thinking, but let's not go there yet. We don't say that when we hear this story, but we look at ourselves behaving in a somewhat analogous fashion, and those of us who are paying attention feel a great amount of concern and responsibility about this. So what is the difference? What have we got that the cyanobacteria didn't have? In an attempt to parse that question a bit more finely, I've sort of categorized the different kinds of catastrophes that can happen to planets. And I suggest there are 4 kinds of planetary change categorized with respect to the influence of life. So the first kind, planetary change, planetary catastrophes of the first kind I call random catastrophes. These are just the things that happen to planets because of the dangerous universe we live in. An asteroid comes along and ruins everybody's day, or a massive pulse of volcanism from some glitch in the interior convection of the Earth results in a huge pulse of flood volcanoes that put many gigatons of CO2 into the atmosphere and cause a drastic episode of global warming or change the sea level and lead to mass extinction. This has happened many times in Earth history. These are just disasters where life has nothing to do with it. Life is just in the wrong place at the wrong time, an innocent bystander. This is when bad things happen to good planets. The second kind of planetary change is what I call biological catastrophes. This is when the evolution of a species or some set of species so transforms the world. Some species are so successful at doing what they do, they so transform the world that they cause global changes that lead to extinction of many other species. And I already gave you the example of the evolution of photosynthesis and what happened when that really took off, which is why I symbolize this with a green leaf. There are other examples as well. The third kind of planetary change, this is what I call inadvertent catastrophes. And this is where the cognitive processes start to come into the picture. This is when a very clever species comes along and develops the capacity for technology and and they're very successful at solving local survival problems. So successful that they proliferate around the planet and change many environments to suit their further development. And in the process, at first completely unaware that they are doing so, they start to cause global changes to the environment, to the planetary environment. This is symbolized here by traffic because it's an example of what I call the Anthropocene dilemma. When your sphere of influence greatly exceeds your sphere of awareness. You can look at this in terms of systems analysis or cognitive development. Think of the cognitive development of a child who has not yet become aware of their influence on the world. So you have to watch them carefully because they're going to hurt themselves or hurt other things because they'll crash into things. This is when your sphere of influence exceeds your sphere of awareness. And in some ways, globally, in terms of our collective cognitive development, we're at that stage of that child who has not yet fully become aware of their influence or is struggling to gain that maturity. And I symbolize this because of by traffic, because here is a species very good at solving local survival problems. Like in this case, how do you get from Alameda to Berkeley at rush hour? And each of these cars is being driven by a person with agency, and it works very well. You can see obstacles and steer around them, step on the brake if you're going to hit something. They're in control. But then you can also look at the system as a whole and ask who is driving the global transportation system. And the answer is kind of nobody. We're participating in it. We're watching it as if somebody else is doing it, but we're not really, nobody's really in control of it. So that's what I call the Anthropocene dilemma. And some examples of these changes of the third kind, the most obvious and the most urgent, of course, is our emissions of carbon dioxide in the atmosphere and what that is doing globally to our climate. And you all know this story, so I'm not going to dwell on it. But here in the upper left, of course, is the Keeling curve, where in my lifetime, the amount of CO2 has gone up by about 30%. Not a minor change. And of course, this is out of date now. It says 395. Now it is a few years out of date. It's over 400. And this is a great animation that I got from California Academy of Sciences, where you can see where the bulk of the CO2 is coming from, the industrialized urban areas. And even if you watch this carefully, you can see where the sinks of CO2 are, largely in the most forested areas. So there's actually a lot of information here. And of course, you're all very familiar with the dangerous effects this is having, like the sort of frightening decrease of the sea ice in the Arctic. So I won't dwell on this. It's not because it's not important, but because it's a story you know, and I want to fit it into a larger context. So other examples of inadvertent change, well, a really important one, and this is also a story you probably mostly know, but the dangerous destruction of the ozone layer, which, by the way, we discovered in part because we were exploring the planet Venus. And I want to be really careful how I tell this story, because as far as I know, Ron Prinn might be here. But scientists who were interested in the chemistry of the upper atmosphere of Venus became very aware that chlorine catalytically destroys some oxygen compounds. That was part of what helps explain the mystery of where all the oxygen is in the upper atmosphere of Venus, where we know CO2 is being destroyed by ultraviolet radiation, but we weren't finding all the oxygen that should result. And then some people said, well, wait a minute, is there chlorine there? Yeah, well, chlorine catalytically destroys oxygen. And then some other scientists read those papers and said, well, wait a minute, what about all this chlorine that we're putting into Earth's atmosphere with these nifty new environmentally safe refrigerants called chlorofluorocarbons? And they looked at that and they said, oh, wait a minute, uh-oh, not so nifty and environmentally safe when these chemicals, which are fine and non-toxic down here in the troposphere where we live, when they diffuse up into the stratosphere and they get decomposed photolytically, and the chlorine, the C, one of the C's in the CFCs, nick off, and those naked chlorines start destroying the ozone, which forms this layer which is one of our planet's self-defense layers against dangerous ultraviolet radiation. So anyways, this was discovered, fortunately on time. We would have discovered it anyways without planetary exploration, but it might have been a few years later and a little bit too late. We sort of discovered this in the nick of time, and as you can see, in the 70s, it was rapidly deepening this ozone hole through the 70s and 80s, and then it starts to kind of level off around 2000 and into the current century. And that is because what happened was the scientists sounded the alarm about this problem, and then there was a vigorous global discussion about this. It was really more of a fight than a discussion at first. There was denial. There were the companies that were making a profit off of these chemicals, funded scientists to do questionable studies proving that this was a hoax. And there was a lot of the dynamics we see playing out now with some of the arguments about what to do about global warming played out earlier with this question. But the story is a good one in the sense that has not quite an ending, but a good sort of third act that we're in now, which is that the truth won out. And it became so obvious that this was what was going on that even the companies that were manufacturing these CFCs sort of got on board with the idea of making global agreements. There were treaties signed that were honored globally, most notably the Montreal Protocol for the reduction of ozone-destroying substances, or I forget the exact name, the Montreal Protocol. It's mostly worked. It's been honored, and the fix is working. The ozone hole is on its way to being mended. It naturally takes about 50 years or more, even if you just stop these emissions entirely, for the chemical reactions to occur naturally that repair this. But we are on track. So, and by the way, it's not that those companies, DuPont mostly and other companies, suddenly decided to abandon the profit motive. It's just that they saw the writing on the wall, and they realized they could make a profit by manufacturing the replacement chemicals that would be needed once these agreements were put into effect. So they did not abandon their stockholders and their desire to make a profit, but they were guided in that quest by this global regulatory regime, and they channeled that into making materials that did not threaten the life support systems of the planet. So maybe there's a little fable there, but at any rate, I'm belaboring this because the ozone problem is an example of this third kind of planetary change, inadvertent, but it's also the way I'm going to introduce the fourth kind of planetary change, which is intentional. Because indeed, this at least shows that we are capable of a different way of interacting with our planetary system, a way that is consonant with the knowledge that we have about Earth system science and suggests at least the possibility that we can conduct ourselves in a way that incorporates that knowledge into our technological and economic systems. So what would other examples of intentional change be? Well, obviously the most crucial right now is the need to transform our energy systems into ones that are not destroying the natural systems we depend upon. The good news is this is clearly happening. We're moving in that direction. The frightening news is that it's happening slowly. It's quite clear to me that 100 years from now, we will not be burning fossil fuels. And there will be a post-fossil fuel global economy. The question is, how quickly will we get there and how much damage are we going to do along the way? That's really, in a way, the question of our age. Looking a little bit farther into the future, there are other threats to global well-being that we can imagine applying this intentional mode. And the fact that we can imagine this, to me, leads to the perhaps uncomfortable conclusion that we are obligated to do so. If we can conceive of a global threat, not just to ourselves, but to other species, and then we have the ability to do something about it, maybe there's what I think lawyers call a duty to rescue, where you don't walk past a burning house and not do anything about it. If there's somebody there you could help drag out. So looking on longer time scales, I mentioned earlier the impact threat. That's something we think of in the past, but of course it still exists. It's just that it manifests on a longer time scale than we're used to thinking about. One of the points I try to make in this book is that we need to think of ourselves on longer time scales than we've done in the past, and that we need to think in this multi-generational global way so that even problems that are not immediate need to be on our horizon. And if we stick around for another several thousand years, say, there's no question that at some point this will become a more acute problem. The good news is that we can probably deal with it. This animation is based on real data. Each one of these insect-like objects here is a known Earth-crossing object. So you can see Mercury, Venus, Earth, Mars, orbits Jupiter out there. And each one of these is a known object with an orbit that crosses the Earth's orbit. So there's a lot of stuff out there that will eventually, some of which will eventually hit our planet. This is not something you need to lose sleep over tonight, but it is something that as a species thinking of ourselves on a longer time scale and with the ability to forestall this kind of potentially biosphere-killing disaster, I think we have a responsibility to have a plan. And the good news is that we actually know how to do something about this. I don't think it would be that hard. Chances are we'd have years, probably even decades, of warning, and there are people working on this, and we actually have ideas about how, you don't have to go up there with a nuke with Bruce Willis and blow it up. In fact, that's a bad idea for how you deal with this, because then you might end up with a radioactive swarm approaching the Earth. But all you really need to do is give it a little nudge, change the orbit by a little bit, and there's a number of interesting designs for ideas about how to do that. So we will have a handle on this. In the long run, there's a section in this book that I call the Big Payback. I think it's conceivable that in the long run, humanity could save many more species than we are currently threatening. And that's not at all to get us off the hook. We have to do everything we can to halt the wanton destruction of habitat and species and climate change that we're doing now. But I think it's important for us to have a vision not just of what kind of future we want to avoid, but what kind of future we want to create, what kind of role we want to play on the Earth. And so in the long run, I think we can imagine ourselves playing this more constructive role. Another consideration that falls into this category of potential changes of the fourth kind, potential intentional changes, has to do with climate. We're under the illusion sometimes, some of us, a lot of us, that left to its own devices, the Earth would be fine in terms of climate, that if humans just stopped messing with the planet, that Earth would be, that we'd have an earthly paradise forever. Of course, that is an illusion because we've come along at an unusual time. Our roughly 10,000 year tenure here as a civilization building species has been characterized by relatively warm and stable climate. That's an anomaly. It won't last. If we imagine ourselves being here for as long as we've been, imagine ourselves again being here for another 10,000 years, or say 5 times as long as we've been here, 50,000 years, then we will definitely have to deal with this, because those Milankovitch cycles, those cycles of ice ages and hothouses, there will eventually, left to its own devices, the Earth would go through another ice age, and our civilization would not survive that, and a lot of other species would not survive as well. So this is not something, if we were here and had something to say about it, that we would necessarily want to let happen, and it wouldn't be that hard to prevent. We've already shown that inadvertently, without even trying, we can push the climate harder than we would like. So if we get to that point of planetary knowledge and self-knowledge where we're no longer behaving in that way, then it wouldn't be that hard for us to more gently put our fingers on the scale. Now these lead to really interesting, a whole interesting new set of conundrums, ethical conundrums. Where should we set the thermostat if we acknowledge that we are setting the thermostat? Who gets to decide? How do we figure that out? And then with the question of extinction, there's another weird one too, which is, so let's say we manage to stop the wanton extinction we're causing now, then what is the right rate of extinction? If we sort of acknowledge that in a way, well, we're sort of in charge now, you break it, you bought it, whether we like it or not, we're uncomfortable with that, but it may be true, then do we say there's no more extinction? Then we're advocating a radical change in a process that's always been part of life on the planet. So we either have that choice, or we say, well, there's going to be some extinction, your time is up. That's uncomfortable also. So once we get over this current phase, I think, looking into the future, we have some tricky ethical challenges if we're really going to imagine ourselves sort of managing a planet. I want to wrap up because I've gone on for a while and I want to make sure we have some time for questions. So I won't really go into a lot of detail, but let me just tell you the last part of the book, or the penultimate part of the book, I get into SETI. And I do that because it turns out that when you look at the math of SETI, the search for extraterrestrial intelligence, and you read the literature and you understand what people who've been studying this from a conceptual and quantitative framework, what they've concluded, the central question of SETI turns out to be the same as the central question facing humanity now as we face our future, which is the question of, is it possible for a civilization to build a sustainable long-term relationship with a biosphere? For a civilization with planet-changing technology, is it possible to turn that corner from threatening destruction with these inadvertent changes of the third kind to ensuring survival with these intentional changes of the fourth kind? So the literature of SETI is full of questions about the potential longevity of civilizations elsewhere in a more abstract sense. And I try to sort of turn the radio telescope around then and look at it as a way of thinking about our own far future. And you can even, if you want, play with the geological time scale. You've seen this before, where on the right here, these are the epochs, and the Anthropocene has been proposed as a new epoch that follows the So we've been in there was the Pleistocene, and then we've been in the Holocene, which is the time basically since the last ice age. And the proposal is that now we're in the Anthropocene, this new time of humans. But the thing is, these epochs are not that big a deal from a planetary perspective. They come and go. There are fluctuations in sea level, extinctions, species come and go. But if you go over to the left side of the geologic timescale, these eons, these are the major transitions in Earth history that each left Earth a fundamentally different planet before and after. And there have only been 4 eons so far. The Hadean, which was hell, before there was life. The Archean, which was sort of marked by the origin of life and was very simple, single-celled life. The Proterozoic, which is when life kind of took over the planet. This is when that great oxygen catastrophe happened and life was Earth was chemically transformed by life. And the Phanerozoic, which is the time when life became big and complex and there were plants and animals. So these were the 4 fundamental phases, and each one of these boundaries is a fundamental transition. If you had visited Earth as an alien astrobiology, you would have not recognized the planet before and after one of these. And I'm suggesting that perhaps we are now at an eon boundary, that if this cognitive influence on life persists and can become a stabilizing long-term factor in the planet, that in fact we will have entered a new eon, which I hopefully call the Sapiezoic, the age of wisdom. And the thing is, if it is to be an eon, it has to be the age of wisdom, because it will only persist if cognitive life does become a stabilizing force. So it's quite possible that it won't. But I define it this way, and it doesn't have the word anthro in it, because I also talk about this as a kind of phase that planets may have, whether or not humans are able to whether or not we are able to enter a Sapiezoic here on Earth. If we don't, it's conceivable that someone else could. You know, there's some other pretty intelligent species on Earth now, to name a few: the crows, the meerkats. Insect colonies show some promise, I believe. Cetaceans, if they could get over that, how to do technology with flippers. The point is, or on another planet, one can imagine a Sapiezoic. So I define it this way as an aspirational thing, but also something that, it's not a foregone conclusion that humans can create a Sapiezoic here, but it gives us something to aspire towards, a vision of what role we might possibly be able to and want to play. So I'm going to close now by just reading you something from the very end of the book. The last chapter is called Embracing the Human Planet. And I do a couple things in this chapter. I trace a little bit more, in a little bit more detail, the evolution of the human species and how we've mirrored the climate changes that I talked about. And I point out that many of the moments that made us human occurred in result to existential threats, where we were almost wiped out. There was a genetic bottleneck 190,000 years ago when our numbers might have been as few as 1,000 or less. And we repropagated ourselves. And in surviving that, we reinvented ourselves and became more social and more technologically adept. In a certain sense, if you will, became more human. And what I suggest is that that's our challenge now, that tendency we have to cooperate and invent our way out of situations is one that we need to draw upon again, and that quality of plasticity and reinvention, we just, in a way, need to do it one more time to get to that next level of planetary coordination. And I believe, despite some recent news, there are long-term trends that indicate that we have those qualities. And the last thing I do in this chapter is I talk about pessimism and optimism. And there's a section that I won't read to you where I talk about pessimism. It's called The Power of Negative Thinking. And I warn against a certain kind of toxic pessimism that I think is prevalent these days, a kind of apocalyptic thinking and a proliferation of certain metaphors we use to describe ourselves, of metaphors of crime and disease, which do tell a true part of our story on this planet. But I worry that if we sort of concretize those visions of ourselves, that it will impede our ability to reimagine ourselves. And I suggest some other metaphors that I think also contain some truth, but also the image of of childhood and the potential for maturity and awakening. And the very last part of this book, then, I talk about a sort of taxonomy of optimism. I'm just going to read you that, and then I'll stop. And what I'm going to read you here is almost the end of the book. I'm not going to read the last 2 paragraphs of the book, because I don't want you to know how it ends. I want it to be a cliffhanger. All right. Right now, the subject of the future is rife with anxiety. Visions of apocalypse dance in our heads. The topic of the Anthropocene is often associated with doom and gloom, with an "is the earth fucked" mentality. This is understandable, but it's not the whole story. Let's not dwell on these prophecies to the point where they become self-fulfilling. I propose that, on the contrary, the true Anthropocene is something that should be welcomed. Though it is yet only in its infancy, it can be glimpsed. Don't fear it, learn to shape it. It is the awareness of ourselves as geological change agents that, once propagated and integrated, will provide us with the capacity to avoid doom and take our future into our own hands. Understandably, we are uncomfortable with our role as reluctant planetary engineers. Discomfort sometimes manifests as self-loathing and denial. But this is our task, and we can't afford to wallow. It's time to human up. We have to stand and face it, get up on our big bipedal frames and look in the mirror. Wake up to find out that we are the eyes of the world. Earlier in this chapter, I described flavors of pessimism. There are flavors of optimism, too. There's cosmic optimism, stemming from a belief that the universe in its vastness bends towards life and intelligence, and that what happens here doesn't really matter because there's plenty more where we come from. There's data-driven and historically based optimism, which focuses on positive indicators, of which there are many. Poverty, malnutrition, and infant mortality are in retreat globally. Levels of education are on the rise. Communication continues to become cheaper and easier. Population is plausibly heading towards stability. Solar and wind energy are getting cheaper and will continue to do so. These are all trends toward human freedom and environmental sustainability. There's pragmatic optimism. We really don't know what is going to happen, so why not spread hope and encourage engagement? Exponential technological innovation is transforming our world in surprising and accelerating ways. Possibilities that until recently seemed magical are now imminent, rendering the future frightening and exhilarating, but above all, unpredictable. Where there is uncertainty, there is also hope and choice and room for faith in ourselves. I believe we're just getting started on this planet. Nobody knows the odds of our being able to navigate the evolutionary obstacles before us, but there is a real hope, and it is this: that our evolving technological capacities can allow us to maximize our innate social prowess, equipping us to meet the novel threats we have accidentally created and to become something new in the process. We have done this before. All right, that's it. Thank you.
Thank you, David. I'm Richard Benzel, a planetary faculty member here, and I'm going to help Dave with the questions and answers, and then remind you in just a few minutes there'll be a reception over in Building 54. And there are books available outside, and if you carry those books to the reception, you can meet David there as well. Yes, please.
So, sorry I got here late. Interesting. What I heard was quite interesting. And the first question is, can you elaborate on this rather intriguing period when you said we were down to 1,000? How did that happen? And more specifically, how do you think we managed to sort of recover as a species or a subspecies?
Yeah.
The other thing is, I'm glad to see the word wisdom, in the end, at the end here. If we divided it up between human cooperation and technology, it seems to me that we need to pay more attention to the cooperation side than to technology as the ultimate answer. So could you speak to that? And you alluded to the current administration, I think, at least once. Not to put it all on that, but where's the evidence that we're learning how better to cooperate and live with one another in the ways that I think are implicit, if not explicit, in what you're talking about?
Yeah.
So I want to paraphrase this slightly.
Yeah.
Well, no, go ahead.
Oh, yeah, okay, yeah. I thought you were volunteering. Okay, so, so I'll try to remember all three questions. They're three very good questions. The first one, what's with this genetic bottleneck that happened 190,000 years ago? So the evidence, there are a couple lines of evidence. One is that genetically, human beings are remarkably undiverse compared to other large mammals. We are virtually all the same. And that has been traced back to a time when there were very few humans. And and this isn't like 100% ironclad. There are, paleontologists still are working out a lot of this details, but there is a very solid body of suggestion that this relates to a climate, an ice age that was occurring at that time. The climate of Africa, which is where all of our ancestors lived at that time, Africa became largely frozen over to the point where hunter-gatherers couldn't do what they had been doing because the game died out and there wasn't that territory to hunt. And there's an archaeological site at the very southern, almost at the very southern tip of Africa, a little bit, about 100 miles to the east of Cape Town, called Pinnacle Point. And this is the work, by the way, if you're interested in learning more about this, there's a scientist at the Arizona State University named Curtis Marion, who this is really based on the work of his group. And there's a great Scientific American article about it that talks about this. But it is believed that this site, Pinnacle Point, may in fact be the origin site of modern humans, and it may be where a small band of humans survived this time, or pre-humans becoming humans, survived this time. And there's evidence that they first developed there what is known as complex long-chain technology. Complex long-chain recipe technology, which is basically where you are making something that it's not obvious that the starting materials lead to the finishing materials, and you're doing complex thing with heat treatment of rocks and smelting and things where you wonder, how did they figure that out? And it requires new levels of language to pass this on and describe it. It's a more sophisticated kind of cultural and material technology, and the culture and material technology evolve together because you need the language and the ability to tell the stories and pass this on. Anyways, this is one of the first places, perhaps the first place, where we see evidence of that kind of cooperative technology. And they used that to develop new ways of hunting, and in particular, they survived largely off of shellfish and off of the ocean with some of the technology they were building. Interestingly enough, it's also a place we find pigments and evidence of art and self-adornment and a lot of the other things. So we don't really know, but it's a place where it's considered possibly the origin of modern humanity. And we just barely survived by reinventing ourselves in a sense.
And then the follow-up was, how do we know we're in the age of wisdom, or we have...
Yeah, actually there was a second in-between question, which was... Yeah, so that's a great one, technology versus cooperation. I mean, there are these poles now, and one of the things I describe in the book a little bit, there's this, in light of the sort of awareness of that we're, in a sense, in the Anthropocene, there are these two different reactions, and there's a sort of battle going on within conservation between people that consider themselves traditional conservationists and people that call themselves eco-pragmatists or eco-modernists. There's even a manifesto. You can find the Eco-Modernist Manifesto. And the eco-modernists think that we're going to, I'm paraphrasing and making a cartoon out of very smart, serious people's beliefs, but the eco-modernists think that everything's cool because we'll just invent new technologies and save ourselves, and we'll intensify agriculture and intensify everything so that we can leave more of the earth alone, and we'll build, they believe in a high energy future, not a low energy future. We'll just come up with different energy. They're generally pro-nuke, and they think we'll just intensify everything and we'll innovate, and there's no problem. And the traditional conservationists are horrified by that notion. They think, no, what we have to do is reduce our numbers and reduce our imprint, and it's all about restraint and use less energy and solve things through cooperation and not through innovation. And the eco-modernists accuse the traditional conservationists of not caring about poor people in Africa. They just want to save their parks so they can go hiking, and they don't care if these poor people in Africa don't get the economic benefits of development that we've had. And the traditional conservationists accuse the eco-modernists of being crazy technology fetishists that don't understand that we have to restrain ourselves. And my view, and so I try to describe fairly, and I have respect for both arguments. My view is that we actually need some combination of restraint and innovation, that's what's going to save us, and that there are actually very reasonable voices on both sides that are kind of saying the same things. It's just that people like to, it's part of our nature is that we like to polarize into opposing views. And that is part of actually what we need. That leads into your third question. I think that if you look at the history of humanity, we have solved a lot of big problems about how to live together, even though right now we're clearly in some serious conundrums. Imagine talking to a hunter-gatherer 40,000 years ago and trying to describe to them a modern city, how we live now. Maybe that would be as hard as it is for us to imagine that fully sustainable future civilization that we hope to have in a few thousand years from now. But the thing is, when we first lived together in cities, they were horrible places. Not that we've solved all the problems now, but they've gotten better and they're getting better. A huge innovation was the sewage system. We don't think about it because they work so well and they're running in pipes that generally, when everything's fine, we don't have to be aware of it at all. But when we first lived in cities, we just, threw our shit out into the streets, right? And it was terrible. And then we invented sewage systems. So in a sense, what we need to do now is invent the sewage system of the 21st century. And I think we will. I think there'll be a time 100 years from now, like I said, when we won't be burning fossil fuels. We'll look back on this time and think, how could we have? It wasn't that hard. And I believe we'll actually be in the process of repairing the damage. Not necessarily because I believe that we're going to invent some totally utopian world government where we all cooperate, but I think that we are becoming more globally aware, and despite the recent events you alluded to, which we could talk about as a whole other topic, I see as the last gasp of a certain mentality. I think the kids are growing up as more global citizens now, and if we can just get over this and hand them the world, they're going to do okay. But we are the second generation, maybe 1.5, growing up with those images of Earth from space. Oh, how embarrassing, my random desktop. I'll just shut that down. I don't know what's on there. My love letters. We're among the first humans to grow up with these ubiquitous images of Earth from space. I feel like that sense of a global humanity is still new and still proliferating. And like I said, a lot of these signs, if you step back, are very positive. Infant mortality is half what it was 30 years ago. Half. So if you're an average human being born somewhere on the earth, your chance of surviving to adulthood is twice what it was just 30 years ago. And the big change that I think is really also going to save us is that as poverty decreases, and it really is decreasing around the world, and as women get more educated and get more choices, fertility decreases in some of these hot spots around the world. And that is why the projections all show, they show population leveling off for the right reasons, because women have more choices about what kinds of family they have. And of course, men are involved too, but it's education of women seems to be really key. So a lot of these trends are in the right direction. And the last thing I'll say is that the Chinese are getting really serious about climate change. Not because they're suddenly global altruists, but because you can no longer breathe in Beijing. So there's a point at which reality comes around and bites you in the bottom, and you can only ignore it for so long, and eventually the powerful players will line up because they don't want to destroy the world in which they live either. And I see that slowly happening.
All right, let's see if we can take another question. Let's see. Right down here, please.
Those kids, hi. It's been a while.
Thank you. So, first of all, I apologize for the constant harassment in your emails.
No, I appreciate it.
Okay.
This kid's cool.
And the bass has been getting better. But I hope you don't mind me using this quick bit of Q&A time just to thank you. Because understand that I'm just this weird 16-year-old kid from Boston who struggles with all these disorders, and I go to all this. I struggle in high school, and you know, I'm not great socially, but I look at people like you and Dr. Tyson and Carl Sagan, and it's like, oh my God, I want to do that. Like, that is just so powerful to me because I really don't know how I'm going to get there. And as Carl Sagan said, I don't know where I'm going, but I'm on my way. And I just wanted to say thanks, and hopefully I get to replace your job at some point.
Hey, please, you can have it. No, I mean, when I you know, it's in your hands. You know, I mean, when I interact with young people, there's so many of them have this sense of concern, but also like really wanting to contribute. And you're not alone, and it always gives me a dose of hope. So thank you.
We'll take one more here. I'll bring you the microphone.
I hope you're right in your optimism, but just an argument for pessimism here, not even mentioning the political situation. But if we look at the scientific literature as it's coming out week by week and month by month, it seems that if you were to categorize things as indicating things are worse than they had thought, scientists thought they were 10, 20 years ago versus better, where the preponderance of evidence is that things are much worse and the feedback loops keep being described. And so given that state of affairs, will we be able to last long enough for to take action and for the wisdom to set in?
Yeah, I mean, it's a good question and a fair question. And when you say my optimism, and I ended the talk on a note of optimism, but if we sat down and talked, or if you read the book, it's a tempered kind of optimism. I'm very concerned about the 21st century. I think the 21st century is going to be very difficult. I'm particularly concerned about the next few years, or the next few weeks. I mean, obviously there's there's some scary near-term stuff that we urgently have to deal with. So I don't mean to gloss over any of that. I think when you say things are worse than people thought 20 years ago or better, it actually depends on which indicators you're talking about. That's a complex thing we could get into. It's not clear. I mean, the worst case scenario, of course, is that some of these feedbacks kick in up with methane or something. We reach the state where we can't put the genie back in the bottle. I don't think we're close to that, but the fact that we don't know 100% for sure is why it's unacceptable that we're in this range where we don't know for sure. And I mean, personally, I don't think we're going to stick to 2 degrees. I think it's going to be worse than that. I think the 21st century is going to be pretty bad. But I think there will be a 22nd and a 23rd century, and that there will be a humanity, we will have a civilization, we'll have had some damage and loss. And I think that we have to be able to keep in our heads a vision of where we want to go, even while we are very concerned about how we have to act in this century. In fact, I think it's essential that we have that vision to guide the way we act now. And when I say the 21st century is going to be bad, what I mean is I think if we do things, there's a path to get from here to there. It's a question of what path we'll take. And humanity learns in 2 ways. We do have the power of foresight, And to some extent, we can avoid things by playing them out in our heads and in our computer models and then not actually doing them. But we also learn a lot by, touching the stove and going, ouch, and then after a few times, so we learn through tragedy. In my view, it'll be somewhere in between best case and worst case scenario. We'll navigate that path. And if we do things the wrong way, I think the 21st century will be as bad as the 20th century. And when I say that, of course, people say, well, what are you talking about? The 20th century was great. But of course, maybe it was for you and I and our families. I don't know your family. But for a lot of people, of course, all the people that died, the hundreds of millions of people that died in wars and famines and, all that, it wasn't so great. To me, that's the scale of tragedy we're facing again with climate change. But we'll get through it, and there will be a future. So I think that somehow, they say the mark of a mature mind is to be able to hold two seemingly contradictory ideas in your head at the same time. Somehow I think we have to have that great concern and not necessarily optimism about the near term, but still have a vision of how we can see we want to be as a factor on the planet when the dust settles from all this.
All right. So to close, I'll remind you there's a reception over in Building 54 on the 9th floor. For EAPS people, and people know how to find that building, could you sort of wait in the lobby and look for someone who might not know their way? It's a little complex from this building to Building 54, so please help those who want to find the reception. And then I'll remind you that David's book is on sale just outside here. This is the only place where the books will be today. And then David will be heading over to the reception himself. You could have follow-up questions there, and maybe you'll get him to sign the book. So with that, any other final announcements? David, we thank you again.